Leading a startup team, whether you're delivering a sugar rush, stocking coffee, or getting a regular delivery of snacks, Office Depot has solutions that fit every startup culture, from getting those first business cards and stationery to ordering fleece pullovers with your new logo. To learn how Office Depot and the California Technology Council have partnered to bring you savings on all of these startup essentials and more, go to californiatechnology.org/member benefits. I'm Daniel Levine, and this is the Bio Report. Early detection is a critical means of improving outcomes for cancer patients. When cancer is detected at stage 1, patients have a 90% chance of survival. By contrast, if cancer is diagnosed at stage 4, patients have just a 5% of survival. The use of costly and invasive diagnostic approaches have been a barrier to early detection, but new technology has the potential to change that. Laboratory for Advanced Medicine is developing a simple blood-based test to detect cancer at its earliest stage. We spoke to Ken Chahine, CEO of Laboratory for Advanced Medicine, about the company's blood-based test, how it works, and how it's prioritizing indications. Ken, thanks for joining us.
Thank you for having me.
We're going to talk about liquid biopsies, your company Laboratory for Advanced Medicine, and the ability of this technology to provide a non-invasive means of early detection of cancer. Perhaps we can start with the need and the opportunity to change the way cancer is diagnosed today. How is cancer typically diagnosed?
Yeah, look, today we don't have great tools that are really scalable, convenient, and really inexpensive, and that's really what we need. So today, I think many of us are familiar with a colonoscopy. So after the age of 45 or 50, we all have the pleasure of going in and having a colonoscopy. That's essentially a 2-day procedure. You're basically having some kind of sort of liquid diet and prep ahead of time, and then you have the colonoscopy. They usually give you some drugs that sedate you, and then frequently they ask for someone to drive you home. So it's actually not trivial, not convenient, and not particularly cheap. The other one is that everyone's familiar with is a mammogram, and that's looking at just the data from the CDC. I think like 35% of the people who are eligible for a colonoscopy don't take it, and mammograms are on the decline because women really don't like the procedure. So today, those are the two common ones. For things like liver cancer, pancreatic cancer, there's really nothing today. There is no early detection. So this idea of being able to go to the doctor and getting a tube of blood and being able to, from that tube of blood, to accurately determine whether you have not just cancer but early stage cancer is completely revolutionary and a paradigm shift that's going to revolutionize cancer treatment. And the reason I say cancer treatment is because if you look at the data for almost the major cancers, your survival rate, if you get diagnosed at stage 1, is 90% or higher. And for almost any cancer, if your diagnosis is in stage 3 or 4, your survival rates are really dismal, and for many of them are literally in the low single digits. So, this idea of being able to be screened with a simple blood test that's easy to comply, that's inexpensive, is really absolutely revolutionary.
You talk about the test being inexpensive. Do we know what the cost would be?
Well, I mean, look, I can tell you from the standpoint of LAM, we really see this as a mass market opportunity. I mean, this is not your typical diagnostic where there's a subset of the population that would use it. This is something that literally hundreds of millions of people are eligible to take, and so we are thinking about this much more from the standpoint of, can you get the cost of this test and the scale of this test to be a lot cheaper? So I don't know that we have a price right now, but I certainly think that it's going to be very, very affordable for everyone, and that continues to be our goal.
There's been a lot of buzz around liquid biopsies for the past several years. What's the challenge they face in becoming a regular part of clinical practice?
So I would say, as we think about liquid biopsy, that's a pretty broad term, and it's really the definition of it is anything that comes from some kind of a bodily fluid. So it actually could be anything from saliva, urine, or blood. As we tend to hear about it in the popular media, if you will, today, liquid biopsy is really two different things. One is you already have been diagnosed with cancer, and what we want to now know is there a therapy, a particular therapy or targeted therapy that is better for your type of cancer? And so that's one type of liquid biopsy. That's not what we're doing. The other type of liquid biopsy is looking at, again, if you actually have cancer. And the challenges, I would say very broadly speaking, have been two things. One, can you detect tiny amounts of DNA that came from a tumor cell in your body, right? So that one is just, frankly, almost like a limited detection, analytical detection that you need. And I think with confidence now, we can say, yes, we can detect what you call either cell-free DNA or circulating tumor DNA in the blood. So I would say a lot of people can do that. We have that with confidence. The part that's really been a challenge is, sure, you have some cells from a tumor that have died and some of that DNA is circulating in your blood, but there's also a bunch of, let's say let's use the liver cancer as an example. You probably have a bunch of liver cells that are healthy liver cells that also died that are leaving DNA in your blood, right? So the challenge here is when we see this cell-free DNA, how do we know that DNA came from a tumor cell versus a normal cell? And that's really the challenge. And the struggle everyone's having is, what do you look at? And in the past, we thought for a while that you could look at the amount of the mutations that a certain cell had. It turns out that was, not sufficient to give you the sensitivity and specificity that you need for clinical practice. And so where the whole field has been moving now is something called methylation. And methylation, without getting into the details, is basically a modification that occurs to your DNA that is closely associated with what genes are being expressed in that cell. And it's turning out that methylation is a far, far better way of determining whether that piece of DNA that we're investigating came from a tumor cell or not. And that's really what LAM has been focused on now for some time.
I want to talk about the way the test works, but before we do, you joined the company at the end of last year. What attracted you to LAM?
So, yeah, great question. So I, was previously general manager and executive vice president at Ancestry. I joined there about 9 years ago to start Ancestry DNA. I was sort of, employee number one, built that business up, became incredibly successful. And, we had touched the lives at Ancestry of, 5 to 6% of the U.S. population. So for me, I had launched DNA. We launched a very good health product. We had put the platform on an NGS platform. And so I was really looking for something else, right? And what I was looking for was something that was, equally big or bigger from an impact standpoint, that also had the challenges of scale and cost reduction, because those are things that I really focus on at Ancestry. And when I looked around, the liquid biopsy for early cancer detection, again, I've said this a couple of times, but it really is going to revolutionize the way we think about, cancer diagnosis. And so to me, the impact and the mission of the company the potential scale and the challenges of offering this at a low cost, to me, seemed like the perfect opportunity to leverage, leverage everything that I had learned at Ancestry.
How does the test work? Take me from blood draw to result.
It's a very typical blood draw. It gets collected in a same tube that we're all familiar with, a vacutainer tube. Today it gets sent to our lab, and then at our lab, it doesn't look too different than other DNA tests. You extract the DNA from the plasma that you get. You then do one step, which is called a bisulfite conversion, and then that step, it's just a sort of a precursor to be able to identify which parts of the DNA that we're interrogating have been methylated or not methylated, and then you basically do a sequence, and you can do that through either a PCR technique or NGS, and then ultimately what you're looking for are pieces of the cell-free DNA that have a higher percentage of methylation at certain sites that we have, through a lot of large samples and AI, determined are good predictors of whether that individual has cancer.
And is this a CLIA lab model, or samples all sent to your lab?
Yeah, it's a very typical CLIA lab model. So yeah, we have a CLIA lab that does all of it.
And what is the result the doctor gets? Is it some clear yes, no?
Yeah, that's a great question. So there's really two ways that you can look at it. In our clinical trial that we're doing with the FDA, it is a yes-no answer. However, in our sort of laboratory developed test, or LDT model, it is a quantitative test. And so you could envision, right, the test having, you come in and you're like, oh, Danny, you might be a little bit higher than normal. Come back in 3 months, 6 months, a year, right? And then track it over time. But what we see is it's quantitative. And so ultimately, I find that to be a lot more helpful than a yes-no. And so that's what we've been sort of giving physicians, is sort of this sort of risk scale rather than a yes-no.
And you say you're looking at methylation. So as I understand it, methylation would prevent a gene from expressing, as opposed to there being a mutation that you're looking for. Is that correct?
That's correct. Yeah. So we're not looking at mutations. We're looking at the methylation patterns, and the methylation pattern, as you correctly point out, we've known for a long time, is really important in the expression of genes. So we know that they could either turn on or off genes. And again, we're, to be honest, we're fairly agnostic as to exactly what that methylation marker is doing from a biological standpoint. We're really looking at large amounts of data in AI and saying, when we see this, it is predictive of cancer, or when we see this, it's not predictive of cancer. And so we're kind of taking a little bit more of a, again, 30,000 foot, AI machine learning type approach to understanding the algorithms that we use.
This isn't a pan-cancer test, but a test for very specific types of cancer. Your lead indication is liver cancer. Why liver cancer?
So to the first part of your question, correct. We do have some markers highly predictive of cancer, period. There was a paper in Science Translational Medicine that was published January 1st of this year, which uses what we call a pan-cancer marker. So it's not necessarily a pan-cancer test, but it's a pan-cancer marker. And that one, really gave amazing results in a prospective study of 1,450 patients that were undergoing a colonoscopy and took our test, and there was nearly 90% sensitivity and specificity with the colonoscopy. So we do have certain markers that are pan-cancer markers. We believe that in the at least beginning stages of this, the right way to do this is to have cancer-specific tests. So what we've done for the liver test is we have a few markers that are specific of, quote-unquote cancer, and then we have other markers that are more specific to the liver specifically. And the reason the liver was chosen first, and I was not here to take credit for it, but I really love the application, is that today in the U.S., if you have chronic liver cirrhosis, your chances of developing liver cancer are so high that the American Association for the Study of Liver Disease has put out a recommendation that every 6 months you should get an ultrasound. And the whole point of the ultrasound is to try to catch the cancer at stage 1, where your survival rates are high. Cancer happens to be one where you catch it at stage 4, your survival rate is less than 2%. And so you're in this surveillance mode. The problem is, if you've ever seen an ultrasound, it's a great tool for certain things that are, that you're looking for that are large in the body. They're not great for looking, the resolution's not great for looking at small lesions. So, for example, if you have a cancer that's only 1 or 2 centimeters in size, which is how we define stage 1 cancer for liver, the ultrasound's not very good. So it only tends to catch, call it 4 in 10 of the cancers in stage 1. And so our test catches around 90% of the cancers in stage 1. And so head to head with the ultrasound seemed, like a really good first indication. And then the second thing is, we have, the companies here in the United States and in China. Half of all liver cancers in China, unfortunately, due to the very widespread hepatitis B and hepatitis C, which also is a huge risk factor for that population. So it made a lot of sense to that's the second reason why it made a lot of sense for us to go after liver cancer.
How are you prioritizing other indications you're pursuing? What's the thought process?
It's a great question. There's a couple different things that we can look at. One, and it's not, there's not one criteria, but it's obviously getting a good proof of concept, which I think the liver is, but also a good market opportunity. And I would say it absolutely is, particularly in China. The other big indications that are frankly quite obvious, to be honest, are things like colon cancer and breast cancer, just because it is, it's basically an age-based risk factor. So those just make a lot of sense in the U.S. because it's huge. And then the second thing, frankly, the colonoscopy is pretty good, but the compliance is not awesome. And mammograms, there's a lot of data coming out that mammograms are probably not as accurate as I think we once believed once believed to be catching stage 1 and stage 2 cancers. A lot of FDA letters that have come out saying that women should be warned that those with dense breasts, in particular, the mammogram is particularly not effective. And so there's a real need there for both of those indications. So those are two that are really big. And again, if you want to go back to China, those are not, really the standard of care in China the way they are here. And so there's a huge opportunity to actually introduce a test. And I can see, countries like very much like a cell phone potentially just moving into a blood-based early detection and sort of just, frankly skip some of the stuff that we're doing today in the U.S. like colonoscopies and mammograms. So those are the other two. But there's clearly no end to, sadly, no end to the number of different tests that you can come up with.
Is there some expectation that you'll be able to get to a single test for all cancers, whether it's a multiple panel test or some other configuration?
I think there's no doubt. I think if you look at a longer arc here of how this thing is going to play out, I would say that we're going to see that a few tests are going to come out that are sort of specific, but ultimately, as we start getting a lot smarter and the analytics of the tests get better and better, I would imagine that, I don't know if it's 10 years or 15 years from now, that yes, there's going to be a single test and you're going to go to the doctor, you're going to get the blood draw, and you're going to determine whether you have cancer. And at that point, there's probably going to be 10, 15, 20 cancers in that single test. So yes, I think there's no question that that's the way this ultimately ends. I think the only challenge in the short term is that there isn't really any precedent for that, and so I think it's going to be much harder to get a pan-cancer test approved, and also just, statistically speaking, if you're just going to take all comers and understand whether they have cancer or not, you have to worry about false positives. And I think the false positive is going to be an issue. So I don't, my own personal opinion is we're not quite there yet, but there's no question that this is how the story ends. It's a simple blood draw for, cancer, period. And then the physician can go from there.
You mentioned a clinical trial earlier. What does it take to validate this test?
Yeah, so basically what you do is you get individuals that have chronic liver cirrhosis, so this is a high-risk population. And then in our particular trial, there are really two endpoints. One is using our test in addition to an ultrasound to improve essentially the sensitivity, which is really the biggest thing here that we want to do, because a person who gets a positive on an ultrasound or would get a positive in our test automatically goes to an MRI as a confirmatory test. And so our endpoints are one in conjunction with an ultrasound and then head-to-head with an ultrasound. And then everyone who gets an ultrasound in our test automatically goes to an MRI. That is basically our truth for whether someone has cancer or not. So that's how it's done. So it's relatively straightforward.
Do you find payers want a different level of validation than regulators? Or are payers demanding something more than the FDA in terms of validating it?
Actually, not really. I mean, again, part of this has to do, even though we haven't, nailed down a cost. I mean, we think that the cost of this thing is going to be, at par, probably lower than the cost of an ultrasound. So just from that standpoint, I think that makes it very attractive. And look, it's just like everything else. If you look at outcomes, your outcomes, if you catch someone with liver cancer, if we stay on that track, much, much, much higher. You have the option of doing a resection or an ablation of the tumor early on, which that opportunity is lost once you have multiple lesions throughout the liver, and obviously if it were to metastasize. And then from a cost standpoint, we all know it's just a lot more expensive, right, to treat the later stage cancer. Some of the chemotherapy and immunotherapies that are out there are extremely expensive. So, yeah, I think the economic argument here is pretty straightforward given where we are, that offering our test in lieu of an ultrasound catches more people early stage and actually improves outcomes and saves money. So far we've had really no pushback, and we're in the process right now of publishing some of the data that we've generated to validate the test, so it's out there in peer-reviewed journals, et cetera, to support the reimbursement.
There are a number of other companies out there pursuing liquid biopsies. Some of them have been able to raise a fair bit of capital through venture financings. How is LAM financed, and where will its existing money take it?
So yeah, look, one thing I would say is that this is a very, very big market. And I joke that when I talk to investors, the one question I never get is, what's the TAM? What's the total available market? Everyone intuitively understands this is really a large market. So that's great. So it's natural that we're going to have multiple players in this space, and as it should be. It just shows that this is a great area to go after. They have raised a fair amount of money. That also shows the promise that investors feel this technology has. We have raised about $120 million to date. Our founder, Dr. Shu Li, who's a very successful entrepreneur, has had multiple startups that have gone public and had other very successful exits. Personally funded this at the very beginning, and then it's been mainly family offices that have funded this up to this point. And right now we're in the middle of a large fundraising round that's actually going quite well. And so our hope is basically to do this next round. And really where we're going is commercialization. So in China, we have completed our enrollment for the trial. We have to complete testing of those samples and do the submission to the regulatory body there. And so a lot of it's going to be around salespeople and marketing, et cetera, in China. And then in the U.S., similarly, right, most of this money is really going to commercialization. A good chunk of it's going to go to continue to improve R&D and build that up further. But a lot of it's really taking the company from this R&D stage to commercialization.
How unique is the company's technology, and does something make it more compelling than what competitors are doing?
Yeah, good. So great question. So I would go back to, again, Dr. Shu Lee, who is an angel investor in the Irvine, Southern California area. This methylation technology caught his attention before it caught, frankly, anyone else's attention. He followed it for a couple of years and ultimately felt that the time was right to license the technology. So we have a very large patent portfolio that was exclusively licensed from UCSD, which is where a lot of this data originated. So one thing that makes us unique, speaking as a patent attorney, is that we have a very robust and large patent portfolio of methylation markers specifically that we've identified that are important in certain cancers. And so that's important. And then the other advantage is that we really are in the two largest markets. And so some of the work that's done in China really helps accelerate our R&D and development. So the way the company functions is a lot of the R&D that's done in China obviously stays in China, but we can actually do a lot of the basic research in AI there. And then then everything gets independently, patients and studies get done in the U.S. to validate it in this population, different ethnicities, et cetera. And so that's been a huge advantage as well, because I think it gives us an advantage of speed that I think, and frankly, cost, right, that in the U.S., our competitors don't have.
And how do you expect the test to be used initially? Is it going to be used for someone suspected of having a specific type of cancer?
I think for liver cancer, if we stay on that theme, it will definitely be a high risk population. So this is not a test for all comers. This would be for someone who has either hepatitis or has chronic liver cirrhosis due to alcoholism or something else. Could be secondary to hemochromatosis or whatever. So yeah, that's the way it's going to get used. Look, physicians are going to want to probably use it in conjunction with their ultrasound for some time, get confidence, and eventually I think it'll just displace the ultrasound. And obviously, two of our hepatology board members are on the American Association for the Study of Liver Disease, and so obviously they'll be watching that carefully, and ultimately we want our test to be in the guidelines, right, as opposed to recommending an ultrasound as recommending our test. So I think that's the evolution that's likely to roll out the way I look at it.
And ultimately, what will it take to make this part of a routine physical?
Yeah, so again, our initial test, to be honest, is going to be on the high-risk population. I think the colon and the breast is also going to be in a high-risk population, and that's going to be either someone who has a family health history or other history of colon cancer at an early stage, or someone just, again, over 45 or 50 is going to be the population. Look, I think it's going to be rapidly adopted, and I think the only thing that's a question here is, when there's confidence that the analytics equal what's out there today, and once that happens, I see absolutely no question that this is going to be rapidly adopted, and it makes me think of sort of the neonatal or non-invasive prenatal testing, NIPT, right? I mean, I was literally talking to someone the other day. Young kid, he's like 30. I'm like, he's going to have a kid. And I'm like, wow, aren't you glad you don't have to do any amniocentesis, as part of the pregnancy? He's like, what's that? Like, no idea what it even is, right? That the concept that someone would actually have a needle be stuck in their, stomach to assess whether, the child had Down syndrome or whatever, doesn't even exist. And this new generation doesn't even know what the old test was. I think it's going to be like that. I think our kids are going to say, let me get this straight. You guys used to have to go to the doctor and have a colonoscopy just as a routine. I think it's going to look just as silly as for them, on that. That's what it's going to be. It's going to be like an IPG.
Ken Chahine, CEO of Laboratory for Advanced Medicine. Ken, thanks so much for your time today.
Thanks, Danny. Appreciate it.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.